All right, so today I'm going to be installing a 6 kV Felicity inverter and a 15 kilowatt hour lithium battery from C-Watt Energy. Now 48 volts input to the inverter, and the battery is also 48 volts as well. So just follow me. I'm going to be giving the step-by-step procedures on how to do the complete installation. I might be fast in the process, but just try to keep up. I will give explanations at intervals as to what I'm doing at every point in time, so that you're able to follow me properly and also follow along the tutorial. All right. Okay. So let's just start. Like, first thing we're going to do is to get our trunking pipes positioned. I need to be very fast because I'm working with time. Start from here. So you put the first nail, then you can use your spirit level plumb to get a straight line. Okay, so you have a trunk pipe. Now note that all the cables, the DC, AC cables from the breakers, all the protective devices, input and output for the inverter, they are going to pass through. They are going to pass through this trunking pipe, so that we are not going to see any cable. We try our best possible to make sure all the cables are hidden. So that's the purpose of this material right here. So the next thing we're going to do is to mount the inverter on the wall. The battery is a floor mounted battery. It has tires, at the end of the battery, so it has already been stuck to the ground. So you release it, you'll be able to move it up and down. So you take it and you've already locked it to one position. So at this point, the battery does not move anymore. Okay, so it's going to be here permanently. So let's take the inverter and mount it. Just try to get the position, the best point to mount the inverter. So you raise, then C. So I think I should take it down a bit. So the screen should be at eye level. Using my height as an average height, the average height of an adult. So is at eye level at this point. Then put your plumb. Ensure it's straight. Go with the plumb with your eye gauge. Then you mark. Okay, it is straight, right? Okay, at this point you can mark like this. One, then two. So we mark the mounting structures for the inverter. You can get it from the carton. Everything is there. Very simple to install. So these are the mounting structures. So we have these expansion bolts, 2 expansion bolts. Now at this point, you're going to be needing a drill machine to get this one into the wall. So I need my drill bits. Use a size 8 drill bits to make sure you don't waste time. Okay, so now let's put this one on top of the battery to prevent dust from entering the battery while drilling. So drill one here. We have marked the middle. So it's an hollow block, or a hollow block rather. You have to be very careful. I was supposed to use this expansion board that came with the inverter, but right now I discovered that the block is a hollow block inside and it's not going to work. So I had to switch to this fissure or a wall plug. So I'm going to use this wall plug, and it's best for hollow blocks like this. It's going to fit in and it's going to be tight. So with this, I can have my screws. I bought 2 screws, 1 inch or inch and a half screws. So when you put them inside, you'll be able to hang the inverter seamlessly. So before then, let's just screw these clamps on the inverter. So we have the screws for that already. I have 4 screws. 2, 3, and 4. So you have to be careful. The inverter came with inbuilt Wi-Fi. Yeah, so this is the antenna for the Wi-Fi connection. So you have to be very careful not to place the inverter on the ground, because it's going to damage this stuff. Okay, so this is it. My inverter has been successfully mounted. How about this? Okay, so that's the Wi-Fi device there. Alright, it's very strong, and it's not actually a heavyweight inverter. It's a hybrid inverter. It doesn't have a transformer inside, and so you can mount it on the wall with those 2 small screws. And so that's it for that. And right now we can proceed to the next step, which is connecting the battery cable to the battery. So when connecting the battery cable to the battery, we try to power on the inverter to see if it would work. Before then, I have to place some trunking pipes around here, because I'm going to route the cable from here, then through this other pipe, then it goes down all the way to the battery. So after that, then I'll have to also install my protective boxes, both the AC and DC protective box, in this manner. So when I have that, I'll do the main wiring, then connect the input and output to the changeover and the DB here already. Then after that, I think I'll be done with installation, and I'll go for the earthing outside. So I'm going to trim for, okay, we have the output here, input here. Okay, then power connection. Then the battery is going to pass through this side. Then through this route down to the battery there. Okay, the battery cable rather. Alright, so let's connect the battery cable first of all. So I'm going to lose the 4 screws on the inverter. 1. That's 2. 3. That's the list. Alright, sorry, I couldn't proceed with the battery connection because I discovered that this cable came with this battery, and so it's meant to fit in. The cable lug is meant to fit into C-watt inverter as well, but because it's Felicity solar, it couldn't fit into the hole provided inside the battery terminal of the inverter. So what will happen? I'm going to take this down to the market and fit in another cable lug that will perfectly fit into the hole provided in this inverter. So for now, I'm just going to skip the battery connection. It is not difficult. I'm going to proceed to the other connections like the protective breakers and connecting to the inverter's changeover and also the earthing. So when I do all that, I'll know it's just the battery connection from the inverter to the battery that is left. So I'll go to the market and get that done, then I'll fix it. So let's proceed with the other steps involved. Now, next thing we are going to do to install our protective boxes, AC and DC boxes, just before the inverter. like this. So what I'm going to do right now is to mark with my, can either use a nail or a screwdriver to mark, then use fissures to drill them onto the wall like this. Okay, so just make sure they flush through the trunking pipe, the side of the trunking pipe. So it's flushed like this. So then just mark. You want to mark 8 spots. It's 1, it's 2, 3, 4, 5, 6, 7, and the last one, 8. So you can also remove the inverter so that we don't get to apply a lot of dust on the inverter. So let's remove the inverter. It's very easy to remove. So when I'm done with the breaker connection, the breaker box connection, and mounting to the wall, then I can fix the inverter and do all the wiring. Okay, so we're done with that. So let's fasten the boxes to the wall using screws. So use the speed of the machine. Then look for the screws. For the battery cable, I had to use an alternative. Now there's these fails that came with the battery and even the inverter. So it's very easy. It's just for you to cut the. I had to trim off the one that was already done. Yeah, I had to trim this one off. Then I connected these fails. You can use a hydraulic crimp to do that. Then you can see it's going to fit into the hole provided easily. Okay, so I've already positioned the red, the positive. Now let's do the negative. Okay, so when it's gone inside, then you can screw it down like this. So it's going to hold it firmly as well. So why using your screwdrivers to work on hybrid inverters, you have to be very careful not to mistakenly tamper with some of the components inside. So I have my 35mm battery cable connected. So let me connect to the battery now. So before you connect your battery cable to the battery, make sure the battery is turned off first of all. The battery breaker must be turned off. Then after your connections, you can put them on one by one, then do your testing. This battery, you don't have to worry about adding an external breaker because the battery came with an inbuilt breaker. Okay, first of all, just test the inverter to see if it's going to come on at all. Ensure you connect positive to positive and negative to negative. Turn on the battery. So the battery is on. I have 45% on the battery. So let's turn on the inverter. So it's on now. So I like to do it from some time to boot up. Then you have your output 229 volts. Okay, so I'm going to go into more settings on this inverter later on. So for now, let's just continue with the remaining parts of the installation, the connection of the breakers, input and output, and so on and so forth. All right, so let's turn it off. So this is the changeover switch. Just mount the changeover switch close to the existing changeover switch in the house. Now it will be easy for you to do a connection. Let me connect my input and output first. So I'm going to make use of ferrule connectors to connect them. So you take the red connector, put it inside, just like this. Then you crimp with this tool. This one. Then negative. Also crimp in the same manner. To ensure a tight connection and a secure connection. So positive, come here, red, connect it. Okay, negative, blue, goes here. And that wire is the earth wire. I'm going to connect that very soon. Then let's connect the output. So therefore, let's terminate the input. The input terminates at this device here, the AVS. So we're going to measure. From here it goes all the way down to this point, and here we cut. Also crimp on that set of fils. this life out. Okay, this is the output from the inverter to the loads in the house. Then connect live. This one goes this way. Some nets here. Okay, I've almost connected everything that is left to connect. Now this is all I have left. We have the PV cable coming straight from the output of this breaker, DC breaker right here on the DC box. It comes down to the PV input of the inverter, which is right here. So you use the red fill on the blue wire, and the blue fill on the black wire. I couldn't get black fills. I was supposed to use blue and black on this one to make sure the color code is consistent. I couldn't get black, so I had to improvise. So this one is going to go in here, then this one going in here. Okay, then the other stuff I've connected the output. This is the output. Connected the output straight up to this part of the changeover. So this is going to be the inverter output that will feed output to this point. From here, you take it to the DB. Then from here, you're going to take the input to the inverter. From here, you take it up to this very breaker right here, the input of this breaker. So I'm going to demonstrate it. You see it. So let's just continue with the rest part of the installation. Thank you. So I'm going to connect this one here now. It's positive. There are no rooms for mistakes. Make sure you connect positive to positive and negative to negative. Now what is left here is the Earth cable. I'm going to connect earthing for this inverter, this DC SPD, AC SPD, as well as the DC SPD. I'm going to connect three separate earth cables on the earth terminal of these devices. I will take them to the earth bar outside. So from here, that's the next thing I'm going to see. I'll take them to the earth bar outside. Then I will dig the ground where the common earth rod is going to get to. So you see everything live when you get there. Then for now, let's just power up this system, connect the output to the DB, and also from the gen and grid input to the input of the inverter. So when we do that, we are done with the connection for the inverter and battery side. So we are left with the panels connection. I'm still expecting the panels. Panels are en route. So when the panels arrive, we're going to take you outside and show you one or two things you need to know about the panel connection. So that's it. So let's just do the needful and then try to do the editing for these devices and power up this system. So the way the connection is done, a lot of you have been asking, how do you connect the DB changeover and everything? Firstly, connect the output of the inverter to this new changeover. You bought this new changeover. Connect the output to this new changeover, either the bottom or the top. I like to use the bottom. Now when you connect it, then what you do, you lose on your existing changeover. You see the output on the changeover, the middle part. You're going to lose the cables there because these cables actually go to the DB straight up. So we have the live and the neutral. So carry the neutral, take it to neutral on your new changeover. The output actually, because we want to change the output from just grid and generator to grid, generator, and solar. But solar will get a single output here. But this one is going to be for grid and generator. It's going to be a combined output. Then this one will be for only solar. So you take this one here, try to stretch the cable. So when it gets here, connect to negative. So you do something like this. Then you connect it. Whenever you use red cable for negative or for neutral, you must try your best to indicate it using the black tape. Very important. So at this point, I will indicate it with the black tape. It's neutral. Then the one here is the live. Open this stuff. Lose it from the regular changeover. The new location is your new changeover. The inverter changeover, or anyone you want to call it. Just don't worry. That's step 2 or step 1, anyone. First, the output of the inverter to this side. Second, output of the regular changeover to the output of the new changeover. Then, at this point, when you switch on the inverter and take this on here, there's going to be light in the house. But let's complete it. The last thing, you can see we have grid, we have generator, then we have one output here. So I'm going to tap from here and take it to where? The top of this changeover. So and again, from the top of this changeover, lastly, you're going to tap and take it to the input of this breaker right here, so that you can use the generator or grid to charge the inverter. Okay, so let's demonstrate that, and that'll be the end of everything we are doing here. So we can go outside and check the earthing. Okay, so like I was saying, this is the firstly, we have the output from the inverter going to this side of the changeover, the one you bought. Then again, from this other changeover, the existing changeover, you remove the wire that was there before. That's actually the load wire that carries current to DB up there. You remove the live and neutral, you take it to the middle of the new changeover you bought. So you can switch from inverter and grid generator to feed into this cable here. Then how do you now get what is supposed to be connected to this point? Now the first one is you take the same output from here, the former output that went to your DB, you take it directly to this place, so that it will now be like a combination of this changeover, gen and lights. The output will now come here. So whenever you take this one up, you have light filling this place. And when this one comes down, you have gen filling this place through this output. Then when you have it here, you can now use this one to alternate between solar or inverter slash generator, solar or grid slash generator. Then the last thing is you connect from here as well to the input of the charging breaker right there. Okay, so this is it. This is the cable. I've already prepared it. So just have to loop it to this one. Pause live to live, neutral to neutral. When you loop it, then it will not only serve as a bypass in case you want to use generator only. It will serve as a source of input to the inverter. So when you want to charge your battery using generator or using the national grid power, all you need to do is to switch on this breaker, because this one's already taking direct voltage from here to the breaker. So when you switch this one on, it supplies voltage to the inverter. All right, so this is the earthing side. Now, normally when you connect your hybrid inverters, you need to make sure all the earthing is done. Yeah, there are a lot of devices we are going to earth on that system. We have the AC surge, we have the DC surge, we have the inverter itself. Then we are supposed to earth the panels as well, but for Felicity hybrid inverter, is specified that you're not supposed to hit the panels. If not, it will start sending leakage currents to the inverter, and that can be disastrous. So we are just going to hit the inverter and the SPDs. Then we take all the earthing from one of these bars to the ground using this earth rod. Now I've already fixed the wire to the rod, and then all I have to do is to make sure I use this clamp to tighten it more in this manner. Ensure it's tight, then you just take it to the ground. Okay, then I'll pass it through this pipe. I want my job to be as neat as possible. So use it. You have it here. Then take it through this hole. Now you have 1, 2, 3, 4, 4 bars where you can connect it to. So I'll connect it to the first one. This is the main wire that takes all the earth into the ground. So all you need to do, just put it on top, the bolt, tie, and tie it properly in this manner. So this one is done. Now after this, what I need to do next is I'm going to go inside. I'll climb inside. I'll bring 3 extra wires. I'll pass them through these pipes. And I'm going to connect them separately to the 3 bars we have here. Then I'll lock. So that was going to be the final step. So then I will look for clips to hold these ones to the wall, up to the roof. So I'm almost done with the connection. I've done the earthing, and these are the 3 earth cables that went to that side where the earth pit is. So I'm going to take one to this first SPD, the other one to the second SPD, then the last one to the earthing of the inverter. Then I need to confirm something, because if you check closely, you see that both the input and output side of the inverter, we have 8 terminals. Then we also have one 8 terminal here, more like a general earthing. So I'm going to confirm if this earthing with continuity for both the input and the output earthing. So there's only one way to confirm that, to use my multimeter to carry out a continuity test to see if the reading is going to be true for this and input and also this and output. So if it's true, I don't need to worry about the input and output. I'll just do for this and it will cover for the rest. So I have my multimeter. So let me use the buzzer. So if it's true, you hear the buzz sound. You get one here. Okay, so it's true. Then for the output, it's true. Then even for the gen input, it's true. So one 18 on this terminal is going to cover for the rest 18. So let's just do that one now. So I can round off everything relating to this inverter and cover the chunk pipe. All that things to do. The panel just arrived, and we need to also mount the panels to do if possible. So this I would cut out these points. Very simple. Use your plier to open it. So this for the inverter. Yeah. Then the DC surge or the DC SPD. Take one there. Cut. Connect. AC surge. So it's now time for me to lock everything, both the inverter, the enclosure boxes, and also the trunking pipes. I'm done. So when I'm done with all those ones, I'm going to test the inverter and I'll engage the loads in the house so you see. I'm doing this to prevent insects and rodents from entering inside to eat the wires. If you know, you know. So I'm going to cover it up to this point until I bring the solar cable down before I cover everything completely. And for the enclosure boxes, cover just the AC enclosure box. For the DC side, I'm only going to guide. I'll not close it completely. I'm about to test this guys, this system to see whether all our efforts will be crowned with success or to be the other way around. I hope not. Okay, so let's see. All right, firstly, let's bring this one down. Okay. Okay. The switch is right here for the battery. Okay. Wow. The guy is on now. It's Felicity 6 kVA solar hybrid inverter. It's even written on the screen IVEM 6048. That's 6 kVA, 48 volts, 6 kilowatts inverter. So we have 230 volts right here. So we can energize this system and see for ourselves what solar can do. Just to let you know that this is 6 kV inverter and it has a PV capacity of about 7,500 watts or 7.5 kilowatts of energy. That's the PV capacity of the inverter. Then 500 volts maximum PV input. Okay, so that's it. So let's engage. Wow. It was light. There was light. So if you want a system like this to be up and running in your house, you know what to do. Just send a DM. Let me know in the comment section. I'll put my number on the screen so you can contact me via WhatsApp, via Facebook, anyhow you want to contact me. So wherever you are in location, Lagos, Abuja, Port Harcourt, Enugu, Edo, Delta, I'm up and running.
Sabisa Forest.
Except for Northern State. You understand the matter. You understand the matter. So okay. The next thing I'm going to show you is how we're going to do the panels connection. We have about 9 panels from Seawatt as well, 9 600-watt solar panels. So we are going to also show you as much as we can the procedures for installing the solar panels, testing from testing to installing the rails and installing the solar panels proper. Then we connect the cable from the roof down to the input of the DC breaker. Then from there, that'll be the end of the video. It has been a comprehensive one, and I'll also show you some settings I need to do on the inverter to make sure it matches the battery's parameters, because this system can hardly communicate with a communication cable the RS485 provided. The cable provided by by Felicity on the inverter, they said only used for parallel communication. And if you check the manual, Felicity can also only communicate via cable if you're using a Felicity solar battery or a Felicity lithium battery. If you don't use a Felicity lithium battery, it's not going to communicate. You have to set it manually. You get the point. So you have to set it manually using user defined settings. So which is still not bad. You can see the just 3 things you need to set: the bulk charge, the you see them. That's the bulk charging voltage 55.8, the floating voltage 55.5, and as well as the low DC cutoff voltage 48 volts. I'm going to do that soon, but for now, let's just take it to the solar panel array proper. Then from there, we do some settings, and that'll be all. We smile again, right? Okay. Thank you. All right. Thank you very much. And these are the panels. We have nice solar panels here from Seawatt Energy. Now, this time around, we are going to be using Seawatts. We normally use Jinko for most of our installations, but these panels are also very good, very nice, and they've been tested and trusted. Yeah, one telling difference is the fact that the terminal is not as long as that of Jinko. It's quite short, but if you're having to do series connection, then when you place the panels side by side, it's not going to be a problem to connect two panels together. The only time it's going to be an issue is when you are done with the panel connection and you have to put the cable inside the roof and it's not close to where you can have the hole to put it inside. That's when you have problems. But if it's Jinko, you already have a lot of accesses to put inside the roof. But as for that, when we get up there, we're going to worry about that. So you can see the panel. Let me get the dimension. So I have my measuring tape here. So let me get the dimension. So I already have Jinko measurements marked on my tape. So let me see how wide or how. Okay, I think the width is the same. This is the mark for the Jinko width. The same width. Then again, let's see they have the same height. The same height. So the same height and the same width as of Jinko, but the terminals are shorter. So let me just measure the VOC. See what is one of the solar panels that come in cartons like this because they come directly from the company. So it's not the type that you see they come in pallets where it can be easily adulterated. They will change the stickers and all that. This one is directly from the company. This is the company seal. You get the point. There's no way you can get this seal. So I heard some persons they know how to make this kind of seals in Alaba. I really don't know about that, but I think if you know what you're doing, if you have the right contacts, you can get the original panel. I bought it for the company directly. So that's for that. You can count on me for that. Then let me get to test the cyclic voltage. I'm going to connect now of this to the hybrid inverter 6 kVA. So let's check the open cyclic voltage for one and see how it's performing at the moment. So it's about past 4, and the sun is still very highly blazing. So let's see what we get from this. It's a monofacial panel. So the mono, that's the open circuit voltage. So you're having 15.93. The open circuit voltage is higher. This is a 600-watt solar panel, by the way. On the nameplate, we have VOC as what? 50.3. So true to what we have on the panel. So I'm having about 50.7. We told us 50.3 and having 50.7. That's a nice job from say what. You can check video it there so that you'll see it well. I think this one is upside down. The cycling voltage is 50.3 volts, but we're having 53, 50 something 0.7 volts. So that's a good indication that the panel is okay and it's sharp. So let's see if we can get short circuit test. Let's short circuit for some seconds, milliseconds, and get the ISC. The ISC weighted here is 15 amps. So let's see how many amps we can get from this. If we short the panels, let's see. Short the panels and see. 9 amps. That's correct. And it's never down facing the sun directly. That's a very good indication that these panels are breathing fire. When you see panels that want to do well, the open circuit voltage test and the short circuit current test will tell you a lot about it. So I think with that we can go to the installation proper. We don't have much time, so let's just quickly finish it up. And so we already have the width on our measuring tape and we already have the length. So we go up there. It's just for us to use the profiles. We get full length for one side. We are going to do 5, 4 on top, 5 at the bottom. You understand? So that we can have we can minimize the use of our cable. You get the point? So I'm going to make sure we on the first step we have full profile length. Then on the second step we're going to have truncated profile length. Then it's the same thing for the other step where we have 4 panels, we have full length. Then we have truncated ones at the top. So that's how we're going to install it. I already have videos on how to install solar panels. So I will see what I can do. If I can also show you a thing or two from today's job. But let's see. We are really running out of time and there's no time. We have to do this stuff as fast as we can. I've showed you every other thing inside, the much I can show you. But let's see what we're able to do from now. Thank you very much. Please stick around. So let's just cover the box and we're done.
Now you go the face down. I prefer me to come and say this thing or something. Because this light now, I'm manager. Everybody. Oh, be around. This one
I'm normally supposed to use the silicone push, but the one I have is not working anymore. So I had to improvise by using my hands to manually apply the silicone glue on top each of the parts I nailed. It's more like a 2-factor authentication to make sure I secure any kind of hole or hidden hole that may be a culprit. By the time it starts to rain, then you hear that there are leakages on the roof. So I just have to manually apply it on as many parts that I can apply to ensure that it is covered. Everything is covered. When you do this, just allow the sun to hit the gum for about 30 minutes. It's going to get stuck on that spot, then to block any hole that would allow water to enter inside. So it's good to incorporate this in your installations also. It's non-negotiable. You can see our arrays are perfectly installed to contain 9 panels on this roof. We have to minimize the space because the roof is not that wide. So we have 5 at the bottom and 4 on top. That's the configuration. That's how the setup will be. Once you series these solar panels plus and minus together, so this is the last panel and I'm going to series it with this other panel. So it's very simple to see. You just connect the sockets together, the plus and minus MC4. So it's something like this. Okay, so you have to be very careful not to match the size of the panels because it's going to be detrimental in the long run.
Yeah.
So you have to find a way to do it. Okay.
To demonstrate. Communicate together. Button. So button.
There are some panel ones when you connect the MC4, you hear a click sound. But this one I didn't hear any click. So we have to do better. Alright. So shift it towards that. Wait, let me bring it up. Push up a bit. So this hand tight, you see that the nut and the bolt start to move together. You get to a point where you start to move together, then use the pliers to hold the tip of the bolt so that you can use the spanners on the nut to fasten it better. Okay, then again, can you please come closer so that you hear me project very well. Now, if you cannot, you cannot match the cells, but you can actually match the frames, the ends of the panels. So this is what you do. Put your leg on the frames, not the cells, so that you can tie this one as well. ensure it's anti first, like this, so I'm using the spanners to tie and it starts pulling out from the boat. Doesn't hold any, so it's okay. Okay. Then at the end you use the air clamp. So shift that side. Shift that one. Alright, okay. Now lock that side. Use the end part, use the air clamps to hold it at the ending of the panel. Just like this. So right now this is the output of the solar panel. We have this one as negative, then up there we have the positive. Okay, like I was saying, for panels that have longer terminals, it's very easy for you to just tuck in the terminal into the roof. Now there's an opening here at this point where you can easily turn this one into the roof, because yeah, it's just lucky that we found an opening at this end. But on the other end, for the other panel, the opening is far away from the ending of the terminal because the terminal is short. For panels that have longer terminals like Jinko solar panels, we have up to about 2 years of length for the terminal, so it can go as far as even to this other side where you have an opening. So if you are working with this kind of panels, you need to try to do some kind of addition. So at this point in time, I'm going to add to the length of the solar panel by providing an MC4 connector. I'll use MC4 connectors to socket in this one and take it to up to this very length where we have the opening. I'm talking about the one up there. So I'm also going to do the same thing for that side because I wasn't able to series the top panel and the other, the bottom panel. We have the negative terminal that side, then we have the positive terminal beginning from this side. So I'm supposed to also socket it together because the distance is wide apart and the terminals are short. I couldn't series it. So I'm also going to create MC4 connectors, positive, negative, then same thing with our positive, negative, then take it to this side into the roof. Then I'm going to take that one and connect to the first panel from this one, so we can have the full series connection across the 9 panels in the string. So for now, I'm just going to tuck this one inside this place. The next time I'm going to do the MC4 connectors. I've already talked about how to connect MC4 connectors in my previous videos. If I still have space in my phone, I'm going to do the video on how to connect the MC4 connectors, the crimping tool and MC4 stuff. So that's all for that. Okay, this is the MC4 connector. So I'm going to connect it to, I'll connect both the positive and negative of the MC4 connector so that we can attach it to the one up there. So let's start. Male MC4 connector, you put the one that has this hole, the wider hole, inside like this. Then use the MC4 crimping tool. Okay, this is the size. So it's properly crimped now. Then you put it inside until you hear the click sound. So, alright. Then you lock. Here's the positive. Then the other side you connect the negative. For negative, you use this one. So ensure it is very tight, so you don't end up having loose connections. Open it. Put this on first, then you can lock it. There you go. Then so this is it. So let's test if it's properly connected with our multimeter. It's connected. So we can connect this one to the side that has the panel, the series connection from top to the bottom. So I'll connect it so that we have all the 9 pins connected together in the string. Then for the other one that has a shorter length, so it also creates something like that for it. See, very tight. This one goes in first. We have this 10 mm cable here. So we are going to connect it in reverse. This positive, or we connect the negative MC4 to this positive, and positive MC4 to this negative, because this positive MC4 we clip into the negative of the panels we have. Negative MC4 we clip into the positive side. So we need to connect it in reverse so that it will match. I don't know if you understand what I'm saying. I guess you do. So this is what I'm talking about. Normally it's supposed to be negative to negative, positive to positive. But if I do like this, I'm meant to connect this blue side to what? To the positive. If I connect this positive cannot socket into the positive. So I have to do something like this. So that when it's like this negative end can socket into the positive of the panel. Then we have positive that will go into the controller. The same thing for this side again. Okay. So let's work it out. All right, so I just finished installing the entire system. You can see the DC side, DC box, breaker box, the AC breaker box, then the inverter itself, as well as the battery. Everything is active and it's energized right now. As a matter of fact, the inverter is powering all the loads in the house at the moment. So let's do a walk down through some of the various settings and also the information on the inverter that we have to know. You can see the battery voltage is about 53.6 volts, then 46 amps from the panels charging the battery. That's a lot of current. Then what else again? The PV voltage, PV1, we have 367 volts for PV1. Then 2.49 kilowatts hour of energy being generated at the moment. Then 53.6 volts battery voltage. Again, 5% load. 5% load, how many watts? We have 251 watts. So a couple of lights are on at the moment and also some other loads charging and all that. So it's working well and everything is going well at the moment. Okay. So right now we are not using anything from the battery because we are generating about 2 points around 2 kilowatts and we are only consuming 250 something watts. So the remaining, if you do the subtraction, the remaining energy it's being used to charge the battery, possess this current, which is the charging current of let's see, charging current of 16 amps right here. Okay, so now one important thing you need to do it's the settings. You need to be able to uh, set the inverter parameters to make sure they align with what the battery, the specifications on the battery. You can see for see what's battery, you check the low DC cutoff voltage, the power, the bulk charging voltage, as well as the floating voltage. The floating voltage is 55.6 volts. Bulk charging voltage is 55.8 volts. Then low DC cutoff is 48 volts. To make sure, you see, if you read for better use, please set the inverter parameter as below. So you're going to do all that settings to make sure the inverter works well with this battery. Since it's not from the same brand and we cannot use a communication cable, you can use a communication cable to connect to communicate the inverter and the battery if it's a Felicity battery. Since it's a different brand for batteries, we need to use user defined settings. So to do that, just come here, click on settings, Then head on to Voc charging. First of all, the battery type, you need to change the battery type to user defined. So you look for the settings first of all. Battery type. Okay, battery type is program 8. Click on it. It's currently at AGN, so set it to user defined. If you set it to lithium and it's not communicating, it's going to be sounding alarm. So set to user defined. Then from there, you head on to the bulk charging. Right now is at 48 volts. That's C4. So we are going to edit this to make sure we get 55.8. So we're going to increase it. Every increment gives 0.1 volts. So bulk charging, it's 55.8. If you don't set the bulk charging properly, at some point it will get to a particular voltage. Even if the battery is not full, the inverter will stop charging. So that's the benefit of setting this bulk charging, to make sure it charges to the full voltage according to the battery. Then this flow charging at 648 volts as well, so you need to change it to 55.8. These settings are not negotiable. You have to do it. If not, your lithium battery will be working like tubular. 5.5 as shown on the battery. Then the next program, that is this BC4, actually the cutoff voltage. So you set it to 48 volts. We leave it at 42, the battery BMS will shut down because it's too low. It will discharge the battery too much to the point that the BMS will shut down. So leave it at 48 volts. Or maybe at best 47.9 volts. Or 7.9 volts. Okay, let's set the year, this date, time, and here. So this is 19, 23, 24, 2025. So the months, 11th month, November. And today's date is what? 28. So let's take it back. The dates and time is very important for you to be able to get the actual value for the energy stored and the energy consumption every day, because this inverter actually calculates the amount of energy produced and the energy used per day, per month, and even per year. So you have to set the time accordingly. Then the hour of the day. What time is it right now? It's about 5, right?
Yeah, 4.
4 what? Okay. 4:09. Yes. So that's minutes. It takes 1 to 9. Okay. Then leave seconds at default. Take count by self is parallel and all that. So home and dry. So let's confirm that the settings are still very active. So we have the battery user defined, bulk charging 5.8 volts, flow charging 5.5 volts, then the load is cut off 48 volts. Okay, fine. Then let's check the charging currents. Charging currents, this BCC, total charging current, both for grid and for solar. Let's kind of increase it to about 70. This battery you can charge with up to about 200 amps. Charging currents up to 200 amps. So let's increase to about 70 amps, okay, or even 80 amps. Okay. So when there's enough sun, the battery gets filled up in a short time. BCC 80 total charging current. Then out of that BCC, this 60 is the charging current from the grid. We don't want the grid to charge too much, because if the grid charges up to 60 amps, that's a lot of energy from your energy meter. So let's take to 30 amps. So if grid and solar are charging together, then grid will not exceed 30 amps. So if the total is 80 amps, then grid will be doing 30 at most, then while solar we can do 50. Okay, if the absence of grid, solar can go up to 80. alone. So that's it. Okay. All right. So frequency 50 hertz, then the output voltage to 30 volts. You can also modify it to 220 or 210 volts, but 230 is still fine. Okay, I think that's all you need to know for now. All right, so it's charging currently, and everything's working well. Yeah, so let's see the battery percentage right now. Okay, 52.7 volts for 6%. Okay, all right, it's going, it's moving, and even the sun is almost almost cut out completely because we finished installation at late hours. So, but anyhow, it's still okay, it's still fine. So, thank you very much. So, please make sure you subscribe to my channel and also just hit the like button. Uh, we keep on providing videos like this, educative videos, to make sure you understand solar energy a bit better, and try our best possible to do what we can to give the best every time. Yeah. So it's not easy. The only thing I need for me is your support, and also just try to do what you can to give me the needed support. Thank you very much. On another video, I'm going to do a full breakdown, a full video on all the settings that's involved in this inverter. There are some settings that you don't need to bother yourself about, but the most important settings I've already done it. But other settings like charging priority, the load priority, bulk charging, all those and everything. We have them in your manual, but most times some persons don't really understand those stuff. But then when I have the time, when I have more space in my phone, I'm going to try to make sure I do that on a separate video, so you can get to understand a bit more about all these things and how they work, and get to understand more about solar energy. Yeah, from me and from this channel. So thank you and thank you and thank you and thank you.